Let's look at the last part, okay, of this third big area, okay, of the process optimization, which is process mapping. So mapping a process make it visible. When a workflow is visible, it then becomes easier to find out all the different types of inefficiency in the current state, and work from there onwards, okay, to make it better or have a continuous improvement. Process mapping, okay, shall be undertaken whenever a team wants to analyze and improve upon any current state workflow. And these are some of the key principles behind process mapping. Also, mapping processes require the input of all the stakeholders involved in that process, and we map the current state first exactly as it is. The goal of the process mapping should be to learn and to improve. So walk through the process to identify the ways and seek opportunities to further streamline, automate, and improve the flow. There are certain hierarchy and level of detail of processes in design and construction that needs to be taken into account when looking to improve our own project or organizational processes. The following diagram describes this hierarchy as well as some specific examples. Any process, no matter at what level, can be further improved and optimized. But a typical first step is to map the current state in order to know specifically where and how to improve. At the highest level, we look at integrated cross-functional processes. It is an integration of each stakeholder, discipline or department's own processes and how they tie together to work towards a specific project milestone. It captures just-in-time information flow from one party to another in order to remove loopbacks or redundancies from inefficient or parallel processes. Example of these high-level processes could be cross-disciplinary workflows during the design phase to include all submittals, handoff, and milestones. Or it could be engineering and procurement systems in the construction, which integrate BIM, cost scheduling, and other construction functions into one data platform. The next lower level will be the single function processes, and they are a series or sequence of tasks to produce a specific deliverable or product. The typical objective of this kind of process is to reduce cycle time. Examples of this could be intensive collaboration or coordination process, or floor casting cycles, or this PBU manufacturing cycle. Next, lower down the hierarchy will be the process flow, and it is usually a standardized step-by-step procedure to produce a specific task. Example could be BIM-based crane capacity planning steps, or BIM to construction site digital surveying steps. There are different process mapping tools available, and for the next few slides, I will be taking you through three specific process mapping tools: the swim lane, the flowchart, and the value stream mapping. Swim lane diagrams. They are cross-functional process maps that delineates who does what in a given process. They provide clarity and accountability by showing both what each stakeholder does in each of their own swim lanes and how each stakeholder's work relate to each other. Why do we want to use the swim lane diagrams in a process mapping? Well, it helps to ensure that the right hand knows what the left hand is doing in a particular process. The information handoff between the entities are clear. Who must receive what from whom? Redundancy between different lanes are highlighted, as well as bottlenecks, wastes, unnecessary steps, and other inefficiencies. It integrates processes between teams or departments, resulting in a more streamlined process. The application of swim lane diagrams can be to the following areas: cross-discipline processes, cross-department processes. So in developing the swim lane diagram, we will put down the various stakeholders, okay, in the form of a horizontal row. And for the various stakeholders, we will put down what are their jobs or their job tasks. And we try to link, okay, the different job tasks all together and come up with a swim lane diagram. And when we have completed the swim lane diagram, we will need to look out, okay, for certain things. One of the things to look out for will be handoff. When a stakeholder hands off a task to another stakeholder, it is useful to look at how that handoff took place, especially how long, and whether or not it is the most effective and efficient way to communicate the information. We also look at possible turnarounds. In a turnaround, the stakeholder must revert back to another stakeholder for clarification or more information before they can proceed with the work in their role. If this is recurring, then it becomes a source of inefficiency. We will also look for parallels and duplicates. When two stakeholders are working on the same work in parallel, thereby creating unnecessary or duplicate work, it will translate into waste. We can also use the flowchart as a process mapping tool. A flowchart is a graphical representation of the sequence of activities used to create, produce, provide a specific or unique input or output. Why do we use flowchart? Well, the flowchart allows us to drill down within a subset or portion of a larger process to show the ground truth reality of what actually happens. The flowchart will distinguish between value creating activities and non-value creating activities. In terms of applications, you can have specific steps to execute an activity. For example, transferring points from the BIM to the construction site, performing an analysis, so on and so forth. Now, typically, we use some of the legend here in order to create a flowchart for a process. And once the process is created, we will need to look out for certain things. We will examine each process step for potential bottlenecks, weak links, poorly defined steps. We will also examine each decision symbol. Can this step be eliminated altogether? We will also examine each rework loop. Can it be shortened or even eliminated totally? We will also examine each activity symbol. Does the step add value for the end user? Typically, we would like to enhance the value creating activities, and we will try to eliminate or reduce the number of non-value creating activities within a flowchart, okay, of a process. Besides the swim lane diagram and the flowchart, we can also use the value stream mapping as a process mapping tool. The value stream mapping is a lean tool that helps to a project team to visualize and understand the flow of materials and information as a product makes its way through the different steps within the value stream. It involves creating a visual representation of the current state of a process or system that includes current data on cycle time, inventory levels, material flow path, and information flow path in order to guide the project team's efforts towards determining an ideal future state. Why use value stream mapping? Well, we use it in order to identify reasons for long lead time and low productivity. We use it to enable people to see the flow of value, and we use it to create a common understanding on how the flow should be. In terms of application, okay, it can be used for mapping processes to be measured in terms of cycle time or lead time, for example, in the fabrication of various components. And it can also be used for processes that perform multiple times. When preparing the value stream mapping to a process, we need to go through 8 steps typically. Step 1, we will select the process to be mapped. Step 2, we will select the team members to be involved when we are doing the value stream mapping. Step 3, we start to collect data and produce current state map. And the data will include the process time, inventory or material information, demand requirements, so on and so forth. Step 4, we will critique the current state, which is to identify areas of waste and opportunities for optimization from the various steps that we have initiated initially to obtain this value stream mapping of the process. And step 5, we will then draw out a future state map based on the current state critiques. Step 6, we will then create an action plan based on the future state map developed and implementation plan to deploy the future state from the current state. And step 7, we will also measure the outcome. Check to ensure that the expected outcomes have been obtained. So far, we have talked about 3 methods to optimize the process. We talked about the swim lane diagram, we talked about flow chart, we talked about the value stream mapping, and all of them is about trying to allow the stakeholders to improve the flow. Flow corresponds to being worked on state. Therefore, to improve flows in a process means to streamline and to improve the smoothness of the work. The following are some components of a process and conditions that can either help or hinders the flow. And it is useful if we know how to identify what helps or what hinders the flow. For example, if we look at the component, it will help the flow if the activity, or as a component, it is value creating. But it will hinder the flow if it is not value creating or it is a waste. In terms of a workflow design, it will help the flow if the item is visible, visible item flow. But if it's not a visible item, it will hinder the flow. In terms of a path, it will help the flow if the path is short, unidirectional path. If it's a long, multi-directional path with a lot of loopbacks, that will hinder the flow for the process or for the system. In terms of series of activities, we want to have no hands-off collaborative patterns. If there's many hands-off and a serial pattern, then it tends to hinder the flow. In terms of resources, all required resources are available when needed. That will help the flow. But if there's any required resources that are not available when needed, obviously that will hinder the flow and it doesn't help. In terms of the people, typically if they are all located at the same place, it tends to help the flow. But if they are dispersed in multiple locations, it will not be so helpful. It may in fact hinder the flow. In terms of equipment or files, if they are easy to locate and to retrieve, that will help the flow. But if they are not so easy to retrieve, then it hinders the flow. On top of that, there are other process streaming tips. For example, if we can, we try to combine several activities into one main activity. We try to eliminate rework activities. We try to standardize the process and the way it is performed. We try to centralize data and decentralize operations. We try to capture data as close as possible to the source, and we try to integrate parallel activities. That will bring us to the end of the process step of the Singapore VDC framework. And thus far, we have covered the 3 areas. We have covered the information handling using BIM as a technology. We have covered the people's area. We have covered the process areas.